Hello, this is Jo from Maths Tutor Me. Today we are finishing off our topic on factorising, and to do that we need to practice mixing all of our different types of factorising together. Factorising using one method at a time is much easier than having them all mixed together, so it's really important that you practice this. So here is a list of the types of factorising that we have learned in this session of lessons. So first of all, we did the common factor, we did grouping in pairs, we did difference of two squares, we did trinomials and harder trinomials. So in our lesson today, we are going to be mixing those questions around and trying to identify and use each of those methods as we come across them. Now, probably one thing to note is that you should always check to see if you can take a common factor out of anything before you try and factorize it further using one of the other methods. Okay, so always keep an eye out for a common factor. Grouping in pairs can often be identified by having the four terms. So if you have four terms, it's quite likely that it will be a grouping in pairs. Difference of two squares usually only has the two terms and it is separated by, has the minus sign in the middle. Trinomials have the three terms. And the harder trinomial has the number in front of the x squared that you can't factorize away using a common factor. Alright, so that is just a bit of a guideline so that help you identify what method to use when. So here are the questions. Question 1, you can see 1, 2, 3, 4 terms. So this is going to be a factorizing in pairs question. So to do that, I can look at my first two terms here and I can factorize out a 2 and a y, which would leave me with an x and a minus 3. Okay. The third and fourth term here, I will need to factorize out a minus sign in order to get it to be like this one, and I can also factorize out a z. That will give me the positive x and a minus 3. Okay, so it's important that I make those the same because then I can factorize further to put the x minus 3 out the front as a common factor and the 2y and the negative z sits in the second bracket. Question 2, I only have two terms here. So this could possibly be a difference of two squares question, but the problem is that I don't have very nice numbers here. So what I need to actually do first is factorize out a common factor. Remember to always look for that. So 5 is a common factor, which would leave me with 1 minus 4v squared remaining. Okay, now this in the brackets is a much nicer expression that we can do a difference of two squares with. So that is when we have two brackets like this, and we square root the first term. The square root of 1 is 1, which goes at the beginning of both brackets. We square root 4v squared, which would be 2v, goes at the end of each bracket, and 1 would be a positive and 1 would be a negative. And there's the answer. Question 3, have three terms, so it's a trinomial. I have a 2 out the front here, but it's not a common factor, so it's actually one of the harder trinomials. So what I need to do is multiply the 2 with the 10, which gives me 20. And I'm looking for two numbers that multiply to give 20 and add to give a negative 9. Okay, 20 would be 4 and 5. I could do 4 and 5. If they were both negative, that would give me a negative 9. Okay, remember, keep a scrap bit of paper next to you if you need to. Play around with your numbers until you find the ones that work. So next of all, we leave our 2x squared. We split the 9x to be a minus 4x and a minus 5x. Okay, use those numbers. And we have a plus 10 sitting on the end. Then I factorize in pairs like I did up here in my first question. So the first two terms I can factorize out a 2x, giving me an x minus 2. The third and fourth term I can factorize a minus 5, giving me an x minus 2. X minus 2 is now a factor, and 2x minus 5 goes in the second bracket. Question 4, I have two terms. This is not going to be able to be square rooted though, so it's not going to be a difference of two squares. All I can do here, I think, is take out a common factor. There is a 4 that is common and also a g in both terms. If I take that out, I'll be left with a g minus 4 out of there would give me 3, taking the g, h. And that is as factorized as it gets. So sometimes it's quite simple. Don't try to overcomplicate things. Question 5. Okay, 3 terms. It's a trinomial. I do have a common factor here though. So let's do that first. 2b squared plus 3b minus 10. And by taking that 2 out the front, I have an easier trinomial here to factorize. So I'm looking for two numbers that multiply to give a negative 10 and add to give a 3. That would be a positive 5 and a negative 2. So for the easier trinomial, we go straight to 2 brackets. The pronumeral b goes at the front of both brackets. And once you've worked out the numbers, the positive 5 and the negative 2, you just slot those in the second spot in each bracket. And there it is. Question 6, 2 terms. No, they look like they can be square rooted. This is a difference of 2 squares. So we can go straight to our double bracket here. Square root of a squared is a, goes at the front. Square root of 64b squared is 8b. One's a plus and one's a minus. Done. Question 7. 3 terms, no number in front of the x squared. It's an easier trinomial. So we have the 2 brackets. X is going to go at the beginning of both brackets. I'm looking for 2 numbers that times to give a negative 21 and add to give a 4. So things that times to give 21 would be a 7 and a 3. A positive 7 and a negative 3 would work. Positive 7 and negative 3 makes a positive 4 when we add them and makes a negative 21 when we times them. Question 8. Something squared and another thing that can be square rooted. This is a difference of 2 squares, just a slightly more complicated type. So here's my double bracket. If I square root x plus 1 all squared, I would just have x plus 1. That goes at the beginning of each bracket. Square root of 25 is 5. That goes at the end of each bracket. I will have a plus in one and a minus in the other. Now this can actually be tidied up though, so we need to do that. 1 plus 5 is 6, so it's x plus 6. And 1 minus 5 is minus 4, so x minus 4. There it is. Okay, are you ready to have a try? Okay, so here is 7 more questions using a mixture of the different factorizing techniques that we've learnt. Pause the video, have a try, and then restart the video to see if you're on track. Question 1, we have a common factor that we can take out of those. A minus can be a common factor, 6 is a common factor, and p is a common factor. Inside the bracket, that would leave me with 18 divided by 6 is 3. I've taken the p, so that's all from the first term. Minus is gone, 12 divided by 6 is 2. I've taken 1p, so there'll be 1p remaining in the bracket. So that's it. First question was just taking out a common factor. Question 2, I have 4 terms, so it's going to be factorizing in pairs. The first 2 terms I can take out y as a factor, which will leave me with 10x minus 1. The third and fourth term I can take a negative 2 out as a factor, which will give me 10x minus 1 again. So because I have 10x minus 1, that can go out the front as a factor, I can put the y minus 2 after it. Question 3, 2 terms. So I'm looking for a difference of two squares here. Let's try taking out a common factor first. 5 is a factor. 80 divided by 5 goes 16 times, minus f squared. That is a very nice difference of two squares there, so leave the 5. Square root of 16 is 4. Square root of f squared is f. One's a plus, one's a minus. Done. Question 4, 3 terms means a trinomial, no number in front of the h squared, so it's the easier type. We go straight to the two brackets. H is out the front of each bracket. What times is to give 24 and adds to give a negative 14? 24 could be 12 times 2. If they're both negative, negative 12 and negative 2 would give me that. Negative 12, negative 2 gives me a negative 14. Finished. Question 5. 3x squared plus 10x plus 3. I can't take out a common factor, so this is the harder trinomial. Times the 3 with the at the front with the 3 at the back, which gives a 9. I'm looking for two numbers that times to give 9 and add to give 10. Well, that would be 9 times 1. So let's write that over here, a 9 and a 1. So let's rewrite the question by breaking the middle term to be a 9x and a 1x. So the first two terms I can factorize 3x out of, which will give me an x plus 3. Nothing factorizes out of these, but if I put a plus and I just put them in brackets as they are, then you can see that I have got x plus 3 as a factor. And that would give me 3x from here, and this I would put a plus 1. Question 6 is a difference of two squares. I have two terms here, it's just a harder one. So big brackets, two sets of brackets. Square root of w minus 5 all squared is w minus 5. Square root of 49 is 7. And 7, one's a plus and one's a minus. On the next line, let's simplify it a bit. W minus 5 plus 7 is a positive 2. In the second one, I have a w. Minus 5 minus 7 is minus 12. And one more question here. I have a common factor. G is in all of them, so that will give me h squared minus 7h plus 12. Okay, once I've taken the g out, I have a much nicer trinomial in here to factorize. Okay, so here's the two brackets. I'm looking for two numbers that multiply to give 12 and add to give a minus 7. Well, 3 and 4 times to give 12, and minus 3 and minus 4, if I make them negatives, would give me the negative 7 and still multiply to give a positive 12. So there it is. It's really important that you keep practicing them until you can identify these questions easily and factorize them yourself. So keep practicing, and I'll see you next time. Bye.